Hello students, welcome to the amazing platform of Physics Wallah on PW English channel, my dear students. So today we have came on the second lecture of the chapter solutions, liquid solutions, my dear students. I hope you all have gone through the first lecture, which is of very importance because we have covered all the basic concepts there. Today, what are we going to discuss? We are going to discuss about the concentration terms. I have told you in the first lecture that what are concentration terms. What does concentration term means? Basically, concentration terms means that you have a liquid solution and you know that you have added a particular amount of solvent in a particular amount of you have added a particular amount of solute in a particular amount of solvent, right? Yes. And now you will check as how many grams of solute are dissolved in per X amount of liter solution. So this would be like we will use different units for expressing the same solution. We are clear with the amount, but we will use the amount sometimes in moles, sometimes in grams. And that is the beauty, that a particular solution can have different types of concentration terms. So let's start the amazing session today. So what are we going to cover? We are going to cover concentration terms and we are going to cover a lot of questions. Let's start, my dear students. In last class we have discussed about one concentration term, which was your molality, right? We'll extend that particular topic right now and then we'll move forward to the other concentration terms. So now here you have a question. You have to answer this question, my dear students. This is your A option, this is your B option, this is your C option, and this is your D option. What does this question say? The question says that a 1 liter solution of a solute X has molarity 3 molar. You have a solution which has 3 molarity. Okay. If the solution contains 180 grams of solute X in the solute might be O. So you have to tell that what is the solute. So my dear students, if you are told that you have 3 molar solution, what do you understand by 3 molar solution? By 3 molar solution, we can say that we have 3 moles of solute present in 1 liter of solution, right? Yes, this is the main thing that we can deduce from this expression. Now this is telling you that you have a 1 liter solution. So you have 1 liter solution, perfect, no issues. This means that moles of whichever the solute is, moles are 3. Right? Because in 1 liter you have 3 moles of solute and you have only 1 liter of the solution. Okay. Now next, of a solute X has molarity 3 molar. If the solution contains 180 grams of solute, you are given the particular mass of solute. So the mass of solute is 180 grams, right? Yes, it contains 180 grams of solute. Then you have to tell that which solute is present. Now my dear students, we have deduced whatever information we could have deduced here, right? Yes. Now what are we going to do? We know that we have a solute with moles equal to 3. This means that, ma'am, the moles which is equal to given mass upon the molar mass, here this value is given to be 3 and this value is given to be 180, right? Yes, see, just look at here. You have moles of solute 3 and you are given the mass of solute as 180. If I somehow find the molar mass of the solute, that is the mass of 1 mole of solute, right? Yes, and we know that molar mass for different compounds is fixed, right? Yes. So if I'll find out the molar mass, I can find out which of the following is my solute, right? Yes. So you have these two values. Just put these values here, my dear students. 3 is equal to 180 upon molar mass. So the molar mass would be equal to 180 upon 3, which is equal to 60 grams per mole. So ma'am, the molar mass has came out to be 60 grams per mole. Now just check the options and check which formula has the molar mass equal to 60. That is your correct answer. So let's see which is the correct answer. First is glucose. My dear students, glucose is C6H12O6 and the molar mass of this is 180 grams per mole. This means that this cannot be your correct answer. If you talk about ethanol, then ethanol means that CH3 CH2OH, right? You have to calculate the molar mass of this as well, right? Yes, you have 2 carbons. This means that 12 into 2 plus you have 1 oxygen, 16 plus you have 3, 4, 5 and 6. 6 you have what? Hydrogens, right? Yes. So 6 into 1, I'll write, you will understand. This would be 24 plus 16 plus 6, which is equal to 6 plus 6, 10, 16. This would be here 2, 3 and 4. 46 grams per mole, right? No ma'am, this is also not equal to 60 grams per mole. Now let's move forward to urea. Urea is, my dear students, NH2C double bond O NH2. Right? Yes. Now let's check that what is the molar mass of urea. You have nitrogen 14 into 2 plus you have carbon, which is 12, plus you have 16 hydrogen, plus you have 16 oxygen, and you have 4 hydrogen, so 4 into 1. This would be 28 plus 12 plus 16 plus 4. So this would be, my dear students, 0 and 2, 4, 5, 6, 60, right? Yes. So this is 60 grams per mole, and this is your correct answer. So here the molar mass is equal to the molar mass of urea, which is 60 gram per mole. So X is urea. This is how you need to solve the questions. The questions are not going to be very straightforward. You have to tackle how you're going to solve that particular question. I hope this question is clear. Let's move forward, my dear students. Now, if we see, now we are going to talk about the mixing of solutions. What does mixing of solution means? Now, imagine you have a solution. Imagine you have a solution I have a solution with, let us say, M1 molarity. I have a solution whose molarity is M1, and let us say that its volume is V1. Right? Yes, I have a solution whose molarity is M1 and volume is V1. Right? Yes. Now, if I add this solution with another solution is same, but the molarity is different. Let us say this solution's molarity is M2 and its volume is V2. You have the solution of same component. Let us say aqueous NaOH. I am telling you that this is also aqueous NaOH solution and this is also aqueous NaOH solution. Now, you have aqueous NaOH solution in both the containers, but the molarity of both the solutions is different, M1 and M2. And the volume of both the solutions is also different, V1 and V2. Now what I want to do is I just want to add both of them, right? Yes. If I'll add both of them, then I'll get another solution. Now, my dear students, imagine here the molarity of the final solution will be different, right? Yes, ma'am, it will definitely be something else. So let us say that it is M final. Let us say this is M final, and the volume would also change, right? Yes. So let us say the volume is V final. Let us say the volume is V final for this solution, right? Yes. I hope till now there is no issue because you've understood this. Now, if I ask you that what is the final volume? What is the final volume? V final is final volume, okay? This is the final volume. Now, what would be V final, ma'am? You have two glasses of water. Let us say you have let us say you have 10 milliliters of water here and 10 milliliters of water here. If you'll add both of them, you will get 20 milliliters of water. You're just adding the volume, right? Yes. So you can add volume. So ma'am, V final would be V1 plus V2. I hope there's no issue here. Perfect. Now, if I ask you what will be M final, can I say that this is equal to M1 plus M2? If you feel like that we can say that this is M1 plus M2, this is wrong. This is, my dear students, wrong. Okay. Now, let's understand why we cannot add the molarities like we have added the volume. Because, my dear students, molarity is a intensive property. Just write it here as note. Molarity is intensive property. What is intensive property? It is an intensive property. It cannot be added directly. First write this, I'll explain you. It cannot be added directly. Now, Why can't we add molarity directly? Because you have studied two terms, intensive and extensive, in your 11th in thermodynamics. There were two types of properties, extensive property and intensive properties. The intensive properties are the properties which does not depend on the amount, which cannot be directly added. Whereas if you talk about the extensive properties are actually the properties which depend upon the amount, and they actually can be directly added. For example, if you have two blocks of temperature T1 and T2, if you take those two logs together, can you say that final temperature would be T1 plus T2? No, you cannot add the temperatures directly, right? Same way, my dear students, you cannot add molarity directly, because molarity is a intensive property. Whereas if we talk about volume, then volume is extensive property. It is extensive property, and it can be added directly. So for you, in this particular chapter, this is of utmost importance, that intensive properties cannot be added directly, and molarity is an intensive property. Directly, the properties which could be added are extensive properties, and volume is an extensive property. In fact, my dear students, you can write here as volume, and number of moles is also a extensive property, so you can add the number of moles directly. Okay, so now I came to know that I cannot add the molarities directly, but I need to find the final molarity. So my dear students, you know that final molarity will be equal to total moles upon total volume. Right? Yes, I hope there is no issue here. I have found the total volume. The final volume I have calculated, but I haven't calculated the total number of moles. But I know that molarity is actually equal to number of moles upon volume. So if I need to calculate the moles, then that would be equal to molarity into volume. Is there any issue here? No, ma'am. This means that if you are given molarity and volume, how can you calculate the number of moles? Just multiply molarity into volume, right? So my dear students, if I ask you, give me the number of moles in the first solution of solute, what will you say? Ma'am, number of moles will be N1, and that will be equal to M1 into V1. I hope you're clear with that. See, you've calculated number of moles. You know how to calculate the number of moles. I have just calculated the number of moles here. If I ask you that what will be the number of moles here, you will say that, ma'am, number of moles total here would be M2 into V2. Right? Yes. Since the solution is same, this solution and this solution both are aqueous NaOH, the solute is NaOH. Then can I calculate the total number of moles here? Can we say that the total number of moles would be N final? And what will be N final? Number of moles are extensive properties, so we can add them directly. So ma'am, you can say that final moles would be represented by NF, and this is equal to N1 plus N2, right? Yes. So now final molarity M final will be equal to N1 plus N2 total moles, or I could say NF upon VF, right? Yes. So M final would be equal to, what is NF? N1 plus N2 upon V final is V1 plus V2, right? Yes, this could be your one formula. This could be your final molarity. You can calculate it like this. But if you need to remember the formula, if you need to memorize the formula, I can write the final formula as M final would be equal to, what is N1? See, N1 is M1 into V1. So just put it here, M1 into V1 plus N2 is M2 into V2 upon V1 plus V2. So this is the final formula for calculating the molarity on mixing of two solutions, on mixing of two same solutions, right? Yes, this is how you can calculate the final molarity. I hope there is no issue with that. You can just pause the video and write, and then we'll move forward, my dear students. You can write this as well. Okay. So if mixing of solution is clear, I would never say memorize this formula. I would say just remember you have two solutions. You have two solutions. Calculate number of moles here, calculate number of moles here, add both the number of moles, and you will calculate the total volume, and you can find out the final molarity. You need not memorize the formula, right? Yes. So let's try one question and move forward. Yeah. So here is the question. You have to try the question yourself first. Pause the video and try it yourself, and then see my approach. What does the question say? Question says that you have 0.1 molar and 400 ml of NaOH solution. So I have a solution 1 where the molarity is 0.1 molar and volume is 400 ml, right? I have NaOH is mixed with. So this is mixed with another solution, and the molarity here is 0.4 molar and the volume is 800 ml, right? Yes. So these two solutions calculate the molarity of the resulting mixture. So you have to tell the molarity of the final solution. The final solution would be something here, and let us say its molarity is M final. See, I don't know the formula. I don't remember the formula, but I know that the number of moles here would be equal to molarity into volume. What is the molarity here? 0.1 into, my dear students, always remember that the volume is always and always in liters. Since you are given volume here in milliliters, you have to convert it into liters. So this would be 400 upon 1000. Let's talk up here. You have number of moles here. So the molarity would be 0.4 into volume 800, again milliliters. So I'll have to divide it by 1000. So these are the number of moles here. I have to calculate the final molarity, right? I know that V final would be equal to 400 plus 800, which is equal to 1200 ml, and I'll divide it by 1000. So I'll get in liters. I can calculate the molarity now. What will be the final molarity? N final upon volume final. What is final molarity? Addition of both these number of moles. This is 0.1 into 400 upon 1000 plus 0.4 into 800 upon 1000. I'll have to divide it by the total volume, which is 1200 upon 1000. So 1000 would be cancelled out. This would be equal to 40, and that would be 332, I guess. Yeah, 320, right? Divided by 1200, which would be equal to 360 by 1200. 12 ones are 12, 12 to 24, 36, 36. So this is 10 and this is 3, right? So I hope I am doing the calculation correct. Just check it. 0.3 molar is the final molarity. Just check the calculation. It might be wrong, but the approach would be this only. Okay. So just check the correction, calculation, my dear students. This is how you are going to solve the questions when they are based on the mixing of solutions, right? Yes. Let's move forward to the next question. Okay, so now we have talked about mixing of solutions. You'll practice these questions a lot, but we have to first cover all the topics. So the next topic would be your dilution of solution. What is dilution of solution? See, my dear students, what does dilution mean? I'll just explain you this. Okay, how can we understand dilution of solution? Let us say you're preparing a tea. You're preparing tea. Yes. You've added more sugar. So it is very sweet in taste, right? Yes. It is very sweet in taste. So how can we lessen the sweetness? How can we do that? Ma'am, if you add more of the milk or water, then the quantity would increase, the volume would increase of the solution, but the amount of sugar, that sweetness would be lessen up, right? Yes. So what does this mean? What does this mean? What have you done? Initially, when you added sugar, the sweetness was a lot. That means that the sugar solution was concentrated, was very concentrated. Its concentration was very high because the moles of your solute were very much in that. Okay. Then what you did, you actually added solvent more. You added water. You added water. Right? Yes. When you added water, you added the solvent. When you added more of the solvent, what happened, my dear students? The dilution happened and the concentration decreased and the sweetness decreased. Right? Yes. So, this way we can say that dilution means addition of solvent. Dilution means addition of solvent. Now, just remember, I told you molarity is equal to moles of solute upon volume of solution. It is the volume of solution in liters, right? Yes. Now, imagine these moles of solute are constant. You've not added more sugar, right? Neither you've removed the sugar. The moles of solute were same. Yes. What you did, you added water. So, if you add water, what will happen? The volume of the solution will increase. Yes, ma'am. So, if the volume of solution will increase, and you know that this part is constant, so I can say that molarity is actually inversely proportional to volume here. And if this part is increasing, the molarity will decrease. That means on dilution, the concentration or the molarity of the solution decreases. The molarity of the solution decreases. We can say this. Yes, we have practically been applying this the whole life. Yeah. So now let's read this. Dilution is the process of addition of solvent, only and only solvent, keeping the solute's mole constant. Okay. So dilution is the process of addition of solvent, keeping the same amount of the solute. Okay. Now, in this process, the concentration decreases. I hope you've understood this. Since this part is constant, we can say molarity is inversely proportional to volume. If you increase the volume, the molarity of the solution will definitely decrease. So, the concentration term is actually decreasing here. I hope it's clear. You can pause the video, write this, and then we'll move forward. Okay, so now let's try this with a question. How are we going to apply the concept of dilution on questions? Okay, so here is a question. Just read the question. What volume of H2O should be added? They are asking you that what volume of H2O should be added to 250 ml 2 molar NaOH solution. So basically, what are they saying? They are saying that you have a solution whose molarity is given to be 2 molar and whose volume is 250 ml. Okay, so what you did, you added some water into it. You added some water into it. You don't know, let us say you added V ml of volume, right? You added V ml of volume here. Perfect, no issues. Now you added VML of water here. What will happen? Ma'am, obviously the concentration of the solution would change. The molarity of this solution would change because the volume has changed. The molarity will not remain same. What will happen now? They are asking you that the molarity is reduced to 0.5 molar. In fact, they've told you that the molarity of the solution is 0.5 molar. The molarity of the solution is 0.5 molar, right? Yes. So now just understand what the question is saying. Question is saying that you initially had a solution whose molarity was 2 molar and volume was 250 ml. What you did, you added more of water to it. That is, you added more of the solvent to it. That is, you've done the dilution. Yes, ma'am. If you are doing the dilution and you're changing the volume, that means the concentration will change. That means the concentration will change, the molarity will change, and you will have some final solution, and they have also given you the final molarity of that solution. Okay, they have also given you the final molarity of that solution. So how are we going to calculate? That how much volume of water is added? See, my dear students, when you did the dilution, can I say that if here the moles of solute were N1, then the moles of solute in this solution would also be N1. Imagine if you have not done anything with the solute, you've not added solute, you've not removed solute, then moles of solute will remain same, right? So N1 will be N1 here also. Perfect, no issues. See, if here V1 volume was 250 ml, then what will be the final volume here? You had 250 ml of volume and you added some V volume. So the final volume here would be 250 plus V, and this would be ml, right? No issues here. Perfect. I know that the final molarity actually is always equal to, number of moles of solute upon volume of solution in liters, right? Yes. They have given me the molarity of this part. What is the molarity? This molarity is 0.5, right? So I can say that this value is 0.5. I also know that this value is 250 plus V. But I don't know what is moles of solute. You will say that, ma'am, you can calculate the moles of solute from here. You know that N1 is equal to M1 into V1. Molarity is given, volume is given. You can calculate the number of moles here, which is 2 into 250 upon 1000. We can calculate. Yes. And these number of moles of solute will be same here. Yes or no? Yes, ma'am. These moles would be same here as well. So now we can put this value here. So let's put all the values. Okay. We had molarity 0.5. This would be equal to number of moles. Number of moles we just calculated. 2 into 250 upon 1000. I'll give you the formula as well. Don't worry. Divided by the volume of this solution, which is 250 plus V. You were supposed to calculate V. Can you calculate V now? Yes, it is very easy. See. Okay. This would be in ml. We have to calculate it in liters. So we'll have to divide it by 1000. Then this will be also in liters. See, 1000 cancelled. So this would be 0.5 is equal to 2 into 250 is 500 upon 250 plus V. So now it is all about calculation. So just calculate it. This would be upon 10. Yeah. So this would be 5 is equal to 5000 upon 250 plus V. Right. This would be 1. This would be 1000. So 250 plus V is equal to 1000. And V is equal to 750 ml. So you can say that 750 ml of volume was added on dilution, right? Yes. So this is how you will solve the questions by the concept which you know. But a lot of people, a lot of students actually want the formula. So now ma'am will give you the formula as well for dilution. Okay. So let's write the formula for dilution. See, what does the concept say? That you have a solution. You have a solution. Let us say its molarity is M1 and volume is V1. Now you've added some V dash volume of solvent. You've added some V dash volume of solvent. You got a new solution and its molarity would be M final. Its molarity would be M final, right? Yes. So now how are we going to derive the formula? See, I know that here number of moles of solute will be equal to M1 into V1. M1 into V1, it is very clear. And ma'am, since you've not added more solute, you can say that the number of moles of solute here and the number of moles of solute here will be same. So this means that number of moles of solute is here also M1 into V1. Because on dilution, we only add the solvent. See, now, if I ask you the volume here, you will say V1 and you added V1 volume plus you added some V dash volume here. Right? Yes. So what can you say? What can you say, my dear students? That ma'am, here we have added some volume and this is V dash. This is V dash volume added plus V1. Right? Can I call this volume? Can I call this V dash plus V1 equal to V final? Because this would be the final volume. I hope this is clear with you. See, so now my dear students, what you have to understand is very important. This is the number of moles here, which is N1. This is also number of moles here, N1. This number of mole is not changing, but here your final molarity is M final and your final volume is V final. So here number of moles will be equal to M final into V final. And here number of moles will be equal to m1 into v1, right? Yes. And since you can add, since on dilution no solute is added, so number of moles of solute remains same. So this means that this n1 is actually equal to this n1, or you could say, let's say final was n2, but these n1 and n2 should be equal. n1 is equal to m1 v1 and n2 is equal to m final v final. So this is your final formula for dilution. This is your final formula for dilution. So this is how you can use the formula for dilution as well, or you can just solve the question, because you know what is dilution and you know that on dilution the moles of solute remain same. So you need not memorize the formula, you can solve the question yourself, okay? But if you need the formula, then this is m1 v1 is equal to m final v final. Right? Yes, I hope this is clear. You can pause the video and then we'll move forward. This is clear. Okay. So now, my dear students, what are we going to do? We are going to solve some questions. So these are some PYQs which you need to understand that such easy concepts are actually asked in your exam. So here is a question. Try the question yourself and then see ma'am's approach. The question says that the molarity of solution prepared by dissolving 63 grams of oxalic acid. You have oxalic acid H2C2O4.2H2O. See, and its mass is given as 6.3 grams. So this is your solute, and solute's mass is 6.3 grams. In 250 ml of water, so you can say that the volume of solvent is actually equal to volume of solution, and that is equal to 250 ml. And if I want to write in liters, I'll say 250 upon 1000 liters. Easy, right? Yes. You have to calculate the molarity in moles per liter, okay? And x into 10 raised to the power minus 2 form. So you have to tell the value of x. Okay. So how are we going to calculate? Ma'am, we know that we have to calculate the molarity, and I know that molarity is equal to moles of solute upon volume of solution in liters. I have volume of solution in liters, but I have to calculate the moles of solute. This is my solute, so moles of solute will be given mass 6.3 grams divided by, I don't know what is the molar mass. I have to calculate the molar mass. See how you are going to calculate. You have 2 hydrogens here and 4 hydrogens here. 4, 5, 6. 6 hydrogen plus you have 2 carbons, so 12 into 2 is 24. Then you have 4 oxygens, so 16 into 4 is 64, right? Yes, so this would be 64. Perfect. Next you have oxygen here as well. 2 oxygens, so 16 to 32. Okay, so now let's see. 6, 10, 16. So this would be 6, 1, 6, 10, 12, 126. So 126 grams per mole is the molar mass of your oxalic acid here. The formula which is given here. Okay. So now we have to solve this. 1 upon 10, this is 1, this is 2, this would be 1 upon 20. So the moles of solute are 1 upon 20. Just put them here. Molarity would be equal to 1 upon 20 divided by volume of solution is 250 upon 1000. This is 1, this is 4. So 1 upon 20 divided by 1 upon 4, which is 4 upon 20, which is equal to 1 upon 5. 1 upon 5. So 1 upon 5 is your molarity. Not 1 upon 5. 1 upon 20, right? Yeah, 1 upon 5 it is. Just let me see if I have calculated it correct. 10, 63, this would be 1 upon 20, yeah, 1 upon 20, this would be 1 upon 20 upon 250 upon 1000, yes, this would be, okay, and this will be 4 upon 20, which would be 1 upon 5, which is equal to 0.2. You have to tell in form of x into 10 raised to the power minus 2. You have to tell x into 10 raised to the power minus 2. This would be 2 into 10 raised to the power minus 1, and if I add 10 here and 10 here, this would be 20 into 10 raised to the power minus 2. So my dear students, your value for x would be 20. The value for x would be 20. So here your integer answer will be 20. This is how you have to solve the question. Such an easy question, such an easy question. The tricky part was maths. The tricky part was maths. Chemistry was super easy. So just go through it. I hope you will be clear with the concept. Yeah. What we were given mass of the solute and volume of the solvent. We've calculated the volume of the solution, we calculated the moles of solute, we added into this, and we got the answer 0.2. But we had to give the answer in the form of x into 10 raised to the power minus 2. So the form would be 20 into 10 raised to the power minus 2. So the value of x would be 20. This is how you have to solve the question. I hope it's clear. Perfect. So if it is clear, then this will be your homework question. It is exactly the same type of question. Again, a PYQ, you have to try and solve the question. Be it NEET aspirants, be it JEE aspirants, you all can do this question. Super easy question. So this will be your homework, and let me know the answer in the comment section. Okay. I hope you will all be thorough with this part. Perfect. Let's move forward, my dear students. Now what are we going to start is the other concentration term, which is known as molality. What is molality? Molality is actually denoted by small m. And what does molality tell you? That how many moles of your solute are dissolved in 1 kg of solvent. This is the important part, that this means that moles of solute present in 1 kg solvent. So you are asked that you have to tell how many moles of solute are present in 1 kg of solvent. So if you have to write the formula for molality, it would be moles of solute upon mass of solvent in kgs. The mass of solvent will be in kgs. So if we write the formula, the complete formula would be, you know that moles of solute is given by given mass of solute upon molar mass of solute divided by mass of solvent. Let us say you had mass of solvent in grams. It is given in grams, then you will have to divide it by 1000. This will be your molality. So the final formula for molality would be given mass of solute upon molar mass of solute. Here it will be 1000 upon mass of solvent in grams. I'll tell you what each part actually denotes. Let's write the each part. Okay. So here my dear students, WS denotes the mass of solute in grams. You have mm of S, this will be molar mass of solute, right? Yes, and this will be in grams per mole. Clear? Then you have WS of solvent. This is your mass of solvent in grams, right? Yes, and M is your molality. So this is how you are going to solve the questions of molality. This is the formula. Again, you need not memorize the formula because you know how to calculate the moles of solute. You can calculate molality, moles of solute divided by mass of solvent in kg, right? Yes, but if you want to memorize the formula, here it is. Okay, so now what I want to tell you is that, imagine I told you that you have 3 molar aqueous NaOH solution. So what does this mean? 3 molar aqueous NaOH solution, what does this mean? This means that you have 3 moles of NaOH solution, NaOH solute, 3 moles of NaOH present in 1 kg of solvent. And since you are given that it is an aqueous solution, this means that your solvent is water. Your solvent is water. So this is how you need to find out all the information from just one expression. This was your solution, where your solute was NaOH and your solvent was water. It was 3 mole small m. This means that 3 moles of NaOH are present in actually 1 kg of solvent. Right? Yes, I hope it's clear. This is how you will read whenever the information is given to you, and then you will calculate whatever is asked. I hope there's no issue. You can write this. I'll pause the video. You can pause the video and write the matter. Right? Perfect. So now let's understand this with a question. Let's understand this with a question. What does the question say? Read the question, try the question yourself. It's a super easy question, right? Yes. The question says that you have 4 grams of NaOH added to 100 ml of water. This means that I have the mass of NaOH. First of all, my dear students, NaOH is solute. And H2O, given water, is your solvent. Okay, no issues. Now, you are given 4 grams of solute. This means that mass of NaOH given is 4 grams. Can you calculate the molar mass of NaOH? I have told you, you need to learn the molar masses of first 30 elements. The molar mass of sodium is 23, oxygen is 16, hydrogen is 1, which gives you 40 grams per mole as the molar mass. So can you calculate the moles of NaOH? Yes, ma'am, given mass upon molar mass. This will be 4 upon 40, which is equal to 1 upon 10. So you've calculated the moles of solute. Now you're given solvent as water. To calculate molality, I need moles of NaOH, but I also need mass of water in kgs. Right? But if I see in the question, I have calculated moles, but I haven't calculated the mass of the solvent in kgs. And in question, I'm not given the mass, I'm given the volume of water. How will I solve this question? Think about it. Ma'am, we can very clearly see that we are given the density of water. Now, you need to memorize the density of water as well. That is 1 gram per milliliter. In this question, it is given, but maybe a lot of times in question, density of water is not given, but you need to know that density is 1 gram per milliliter. So, I know that density is equal to mass upon volume. Right? The density of water is 1. Mass of water I need to calculate, but I know the volume of water, which is 100 ml. Right? So can I say that mass of water is actually equal to 1 into 100, which is equal to 100 grams. So the mass of water is 100 grams. If you're confused, you can just change this with the expression which we are using. Mass of water, and this would be mass of water. So the mass of water came out to be 100 grams. So if you are given volume of some compound and you are given the density, you can calculate the mass, right? Yes. So I was given density, I was given volume, I could have calculated the mass. The mass of water is 100 grams, but I need the mass in kgs. So what will I do? I will write mass of water in kg as 100 upon 1000 kgs, right? Just put the values and calculate the molality. What will be the molality? Moles of NaOH. What is the moles of NaOH? 1 upon 10 divided by mass of water, that is your solvent in kg, which is equal to 1 upon 10 kgs, right? Yes. So this is 1 upon 10 again. This will be cancelled out and my final molality of the solution would be 1 molal. So this is how you have to solve the questions relating to molality. I hope there's no issue. You can just go through this part and then we'll move forward. I hope this part is clear. Now let's move forward. Now, my dear students, the next part is temperature dependence. What does temperature dependence tell you? Actually, there are some concentration terms which actually depend on the temperature, but there are some concentration terms which do not depend on temperature. How some concentration terms depends on temperature, but some doesn't. Now, let's understand that concept. When you talk about the concentration terms, my dear students, if in a concentration term, a volume expression comes. If a volume expression comes, then that is temperature dependence. Now imagine you have some mass, let us say you have 10 grams and you have some 100 ml of a solution, right? Yes. If you increase the temperature, what will happen? Some amount of solvent will evaporate, right? Yes. You can say that on increasing the temperature, this volume can change, right? Yes. So I can say that volume is temperature dependent, but if you increase or decrease the temperature, will that affect the mass of that solution? No, ma'am, mass is not affected, right? Yes. So what can we say? We can say that mass is temperature independent. Now, if you have some concentration term in which volume expression is coming, for example, I have molarity, which is moles of solute upon volume of solution in liters. I have molality, which is moles of solute upon mass of solvent in kgs. If I ask you which of them is temperature dependent and which is temperature independent, what will you say? You can say that, ma'am, volume is temperature dependent. If we increase or decrease the temperature, the volume will change. If the volume is changing, you can see the molarity will change. This means that this is temperature dependent. But if I talk about molality, if temperature is changing, there will be no very major effect on the mass, right? Yes. So, ma'am, if you increase or decrease the temperature, neither of the following would have a major change. This means that this is temperature independent. Right? Yes. So this is how you can find out that which concentration term is actually temperature dependent and which is temperature independent. Just write the expression and see whether it has some volume expression in it or not. If it is there, then it is temperature dependent, and if it is not there, then this is temperature independent. Right? Yes. So this is how you do this type of questions. I hope it's clear. You can pause the video and write, and then we'll move forward. So now my dear students, we are going to discuss another concentration term, which is percentage. It will be mass by mass percentage, mass by volume percentage, and volume by volume percentage. I'll tell you one, and the other two you will calculate yourself. You'll find the formula yourself. I assure you that. Okay. So now let's see how are we going to discuss about it. If I tell you mass by volume percent, what does mass by volume? Just ignore this part. Okay. You have to only talk about the mass by volume percent. Okay. So now, what does mass by volume percent means? Mass by volume percent means that mass of solute in grams present in 100 ml of solution. So what does this mean? This means that how much mass of your solute is present in 100 milliliter of solution. In the mass by mass percentage, mass by volume, volume by volume percentage, volume will always be taken in milliliters and mass will always be taken in grams, be it anything. The volume will never be in liters, okay? The volume will always be in milliliters in these three percentages concentration terms, right? Now, what does mass by volume percent tells you? That how much mass of solute in grams is present in 100 ml of your solution. How much mass of solute in grams is present in 100 ml of solution, right? Yes. You've not understood this. You will be like, ma'am, not understood, right? Yes, ma'am will explain you. Now imagine you are given 20% mass by volume, 20% mass by volume aqueous NaOH solution. So from here, I can tell you that my solute is NaOH and my solvent is water. This is the thing which I have derived. My mass, my solute is NaOH and my solvent is water. And my solution is the mixture of both of them, right? Yes. What I can say from here is that this 20% is actually telling me that I have 20 grams of solute. What is my solute? NaOH. So 20 grams of NaOH is actually present in 100 ml of solution. In 100 ml of solution. So this is how you actually read the concentration, the percentage expression, right? Yes. So if you've understood this, you can read the expression. This 30 mass by volume percent of aqueous Na2SO4 solution. What does this mean? This means that you have 30 grams of Na2SO4, because this time Na2SO4 is your solute, and this is present in 100 ml of solution. In 100 ml of solution. Easy, right? Yes. So this is how you are going to read the percentage concentration term, right? Yes. This is the first part of this concentration term. The other part is you have to find out the formula. What is the formula? So percentage mass by volume will be equal to mass of solute in grams divided by volume of solution in milliliters into 100 into 100. This will be the formula for the percentage concentration term. These two things are of utmost importance. If this is clear, then you can solve any question. Now let's solve the question. Do we have a question here? Yes, we have a question here. Just read the question and try the question yourself, and then ma'am will help you out. See, you have 0.4 moles of NaOH dissolved in 500 ml of H2O. Neglecting volume change on mixing, calculate the mass by volume percentage. See, I can very clearly say that my NaOH is solute and water is solvent. Also, I can also deduce from here that volume of solution will be equal to the volume of solvent. So ma'am, volume of H2O will be actually the volume of solution, and that is given to be 500 ml. Right? Yes. I have to calculate the mass of solute. Why? Because when I have to calculate percentage mass by volume, I need mass of solute. What is solute? NaOH divided by volume of solution in milliliters into 100, right? Yes. So for that, I need to calculate the mass of NaOH. How am I going to calculate that? You are given moles of NaOH, which is equal to 0.4. Can you calculate the molar mass of NaOH? Yes, ma'am, we can calculate. Molar mass of NaOH will be equal to sodium 23, oxygen 16, hydrogen 1, which is 40 grams per mole. Right? Yes, perfect. So, if you have moles of solute, you have molar mass of NaOH, then I know that moles of solute is given mass upon molar mass. So, if I need to calculate the mass of NaOH, then what do I want to do? Moles into the molar mass. Simple mole concept. So mass of NaOH will be, moles is 0.4 and molar mass is 40, which is equal to 4 into 4, which is equal to 16 grams, right? So now you have calculated the mass of solute in grams. So you can calculate this mass is 16 divided by volume of solution in milliliters is 500 into 100. This would be cancelled out, 16 upon 5, which is 3.2% approximately. Approximately 3.2% is your answer. So this is how you will solve these questions. So easy questions, right? Yes. You just need to have a thorough understanding of the concentration terms. The numericals are super easy, my dear students. And in questions, the number is given such that your calculation becomes even easier. Okay. So now let's move forward. I hope this is clear. Now you have mass by mass percentage, right? So how are you going to calculate the mass by mass percentage? Just a second, huh? How are you going to calculate the mass by mass percentage? Same way we have calculated for mass by volume, you have to calculate for mass by mass percentage. This will tell you that mass of solute in grams present in 100. This time, because it is mass by mass, this means that solution mass will be used. So how much mass of solute in grams is present in 100 grams of solution? 100 grams of solution. Okay. Let's take an example. Let us say you have 32% mass by mass H2SO4, aqueous H2SO4 solution. How are you going to read this? What will you say? You will say that you have 32 grams of solute. What is your solute? H2SO4. So 32 grams of H2SO4 is present in this time mass by mass. So 100 grams of solution. So it is 100 grams of solution, right? It's very easy, very easy. I hope you'll understand. You'll just find this. No issues. Now let's write the formula. Because now you can write the formula as well. If you have to write the formula for mass by mass percentage, what can you say? This means that mass of solute in grams. Here I want to write mass of solution in grams into 100. This will be the formula for percentage mass by mass. What important thing you need to understand here is that, I'll write it here, mass of solution is always equal to mass of solute plus mass of solvent. Always remember this, my dear students. It is of utmost importance that your solution's mass is always equal to the mass of solute plus mass of solvent. Okay, perfect. I hope this is clear. You can pause the video and write this, and then we'll move forward. Let's move forward to the next concentration term. So here is the next concentration term. What you have to do is you have to do this question yourself. Try this question. Try this expression, my dear students. Okay. Similarly, the same way we've written first two concentration terms of percentage, you can do this as well. If you have volume by volume, this means that this time you are using the volume of solute and volume of solution. And volume will always be in milliliters. So, volume of solute in milliliter present in 100 milliliter of solution. Present in 100 milliliter of solution. Present in 100 milliliter of solution. Let's take an example. Example is you have, let us say, 20% volume by volume aqueous KCl solution. Not KCl, let's say you have H2SO4 solution. So what does this mean? So what does this mean, my dear students? This means that you have 20 milliliters, this time volume, so volume will be in milliliters, of solute. Solute is H2SO4 and it is present in 100 milliliter of solution. It is present in 100 milliliters of solution. This is how you're going to read. If you are asked to write the formula, can you write the formula? Of course you can write the formula. The formula, volume by volume, would be volume of solute in milliliters divided by volume of solution, again in milliliters, into 100. This will be the formula. Easy, right? Yes. Again, the important thing which you need to remember here is that volume of solution is always equal to volume of solute plus volume of solvent. Just don't forget this, right? Yes, if this is clear, you're crystal clear with every part. So this is how you are going to do this part. Okay, so you can pause the video and do this, right? I'll drink water and then we'll move forward. I hope you've written this. Now let's move forward, my dear students. Let's see what is next. Now we are going to apply whatever we have studied till yet into a question. What does the question say? 40 grams of NaOH is dissolved in 100 ml of H2O. So this means that your solute is NaOH and this is given you are given the mass as 40 grams, right? Next, your solvent is water and its volume is given to be 100 ml. Calculate the mass percentage solution formed. Density is 1 gram per milliliter. So my dear students, by mass percentage, they want to ask you mass by mass percent, right? Yes. For mass by mass percent, I know that I want mass of solute, solute is NaOH, upon mass of solution into 100, right? Yes, these both should be in grams. I have the mass of solute which is 40 grams. But do I have the mass of solution? No, I don't have the mass of solution because mass of solution here will be equal to mass of NaOH plus mass of water. Right? Yes. So we need to calculate the mass of water. What is the mass of water? The density is given to be 1 gram per milliliter and the volume is 100 ml. We know that density is equal to mass upon volume. If density is 1, then mass upon volume, mass will be equal to volume and that would be 100 grams. Right? Yes. If volume is 100 milliliter, then mass would be 100 grams. I hope this is clear to you. Now, my dear students, what we can say that mass of NaOH is 40 grams and mass of water is 100 grams. So the total mass of the solution is 140 grams. Now you can calculate the mass by mass percentage. So mass by mass percentage will be equal to 40 upon 140 into 100. This will be equal to 400 upon 14%. So this is how you are going to solve the questions. Just check that whether you have calculated the mass of solution or not, because these small mistakes are actually going to make a major difference in your marking. So be careful and try to solve the question absolutely correctly. I hope this is clear to you. You can pause the video and then we'll move forward. I hope you've noted it. Now, my dear students, let's do a PYQ. A NEET PYQ is here. Just try to solve the question. It is very easy. Which of the following is dependent on temperature? You have to tell which of the following is dependent on temperature. You have molality. Molality means it is molality. Moles of solute upon mass of solvent in kg. So, ma'am, this is not dependent. This is not dependent on temperature because both the terms are of mass. Next, if we talk about molarity, molarity is equal to moles of solute upon volume of solution in liters. Since molarity has volume factor in it, that means that, ma'am, this is temperature dependent and you have to tell the temperature dependent. So option B is your correct answer. Let's move forward. Next, you have mole fraction. You say, ma'am, we've not studied mole fraction yet. So my dear students, mole fraction, actually we'll study about it, but let me tell you, this is also temperature independent. Our next topic is mole fraction. Okay, let me tell you, this is temperature independent. Weight percentage means that mass by mass percentage, and since this expression carries mass factor, then it is temperature independent. So only one factor is temperature dependent, which is molarity. So such an easy question. See, it was asked in 2017. Right? Yes. Let's move forward. Now we are going to solve some questions. Okay, I am going to give you a lot of homework questions as well because you have to solve all the questions. Now see, what does the question say? Calculate the molality of 10% mass by mass NaOH solution. These are the types of questions which are asked to you generally. Write the qualitative definition of concentration unit given to us. This means that you will have to give the definition of molality. I hope all of you can define molality. Molality means moles of solute present in 1 kg of solvent. So this part is theoretical. Just leave it. Write the numerical expression for the concentration achieved. So now we have to calculate the concentration. Let's do that part. Okay. You have molality of 10% mass by mass solution. So first and the most important thing is, whatever is given to you, you have to deduce all the information you can take out of it. Okay, you have 10% mass by mass. What? NaOH solution. So this means that what you can infer from this is, ma'am, we can say that we have 10 grams of solute. What is your solute? NaOH. So ma'am, we have 10 grams of NaOH, and that 10 grams of NaOH is actually present in 100 grams of solution. Why? Because it was mass by mass. So this information you've calculated. You are supposed to calculate the molality. What is the formula of molality? It is moles of solute. Solute is NaOH divided by mass of solvent in kg. Right? Yes. Perfect. Calculate this. This is an NaOH solution. Now, my dear students, imagine you have 10 grams of NaOH in 100 grams of solution. This means that mass of NaOH is 10 grams and mass of complete solution is 100 grams. But I need the mass of solvent. I know that mass of solution is actually equal to mass of solute plus mass of solvent. Right? Yes. So mass of solution is 100 and mass of NaOH is 10. Then mass of solvent will be, we can calculate 100 minus 90, which is 10, which is equal to 90 grams. Right? So 90 grams is your mass of solvent. So you have calculated this part, but you haven't calculated the moles of solute. How can you calculate the moles of solute? If you are given the mass of NaOH, then can you calculate the mass of moles of NaOH? It is given mass upon molar mass. Given mass is 10 and molar mass is, we've calculated n number of times the molar mass, which is 40 grams per mole. So we can say that this is 40. This means that the number of moles is 1 upon 4. Right? Just put these in the formula and you can calculate the molality. Molality would be equal to 1 upon 4 divided by mass of solvent in kg. You have calculated the mass of solvent in grams. So you have to divide it by 1000. So 90 upon 1000, which will be 1 upon 4 into 90 into 1000, which is 100 upon 36 moles. You can solve this question or solve this molality, and this is how you are going to calculate the molality. And actually the general questions which are asked are these type of questions, where you will be given one concentration term, you will have to find the information from it, and then you will be asked some other concentration term to calculate. Okay, so I hope you're clear with this. Let's just revise this and then we'll move forward. You were given 10% mass by mass NaOH solution. So you have found out the information. 10 grams of solute is present in 100 grams of solution. You were supposed to calculate molality. Molality is formalized moles of solute upon mass of solvent. Now I can calculate moles of solute because I have the mass of solute. So I'll divide it by molar mass and I'll get the moles. But I want the mass of solvent. I have mass of solution, I have mass of solute, but I don't have mass of solvent. How can I calculate? I'll have to use this. Mass of solution is mass of solute plus solvent. From here, I'll calculate the mass of solvent in grams, and then I'll convert it into kgs by dividing it to 1000, and I'll get my molality of the solution. This is how you're going to solve this type of questions. Let's move forward, my dear students. Volume percent of NaCl solution of density, this is 30%. Calculate the mass percent. I hope something, let's try this question, but I remember there is a little bit of error. If there's no error, then perfect. Let's try this question. Okay, you have to calculate the volume percent of NaCl. You're given density of the solution as this, and the volume percent is 30%. Calculate the mass percent. Okay, so for mass percent, what do you need? I'll use this. Ma'am, mass percent means mass by mass percent. And this means that you have, this is what you need to calculate. Okay, I'll start from starting. Okay, volume percent of NaCl is given as 30%. This means that, my dear students, you are given mass by volume percent equal to 30%. Okay, so this means that you have 30 grams of solute. You have 30 grams of solute. Yes, you have 30 grams of solute in 100 ml of solution. Why this time volume? Because it was mass by volume, right? Yes. So you've written 30 grams of solute is present in 100 ml of your solution. You have to calculate, the density is given as 1.4 gram per milliliter. This is for this particular solution. You have to calculate mass percent. What does mass percent mean? Mass percent means that you have to calculate mass by mass percent, which means that mass of solute upon mass of solution into 100. See, now you have mass of solute, but you don't have the mass of solution. You have volume of solution. You need to calculate the mass of solution. How can you calculate the mass of solution? You are given density. You know that density is equal to mass upon volume, right? Yes. So mass will be equal to density into volume. Density is 1.4 and volume is 100, which means that 140 grams. So the mass of the solution is 140 grams. Now it is very easy. You have mass of solute equal to 30 grams. You have mass of solution in grams equal to 140 grams. And then you will have to multiply it by 100. This would be 300 upon 14%. So 300 upon 14 will be your correct answer. This is how you will solve this type of questions. Okay, yes, just a second. Yes, perfect. No issues? Perfect. Can we move forward, my dear students? It was a very easy question. You just had to use this concept, right? Perfect. Now we are going to start another very important. Can I give you this as your homework? Calculate the molality of 1 molar NaOH solution. Given density of the solution is 1.2 grams per milliliter. Can you solve this question? Try this question yourself, and if you will not be able to solve, then I'll tell you. This is your homework question. What does the question say? It is very easy, my dear students. It tells you that you have a 1 molar NaOH solution. First, and the most important thing is, write down what it has asked. You have 1 molar solution, just deduce the information. You have 1 mole of solute present in how many milliliter of the solution. right, or liter of the solution. And then you're given the density of the solution, so you can calculate the mass, and then you will have to calculate the molality. Okay, this is your homework question. If you are not able to do this question, then ma'am will definitely help you out in solving this particular question. Now let's move forward, my dear students, because now we are going to discuss about a very important concentration term, which is mole fraction. What does mole fraction mean? Mole fraction actually means that, let us assume you have a solution, and in this solution you have A component, you have B component, and you have C component. This means that you have a solution which three components, which means that you have a tertiary solution, right? Yes, because three components means tertiary solution. Now all of them will definitely have some moles, right? Yes, let us say moles of A are Na, let us say moles of B are Nb, and let us say moles of C are Nc, right? Yes. Now what does mole fraction mean? Mole fraction means that it is the ratio of moles of one component to the total number of moles, Okay, now assume you have to calculate the mole fraction of A. The three components will have their individual mole fractions. Mole fraction of A will be equal to moles of A upon total moles, which is moles of A plus moles of B plus moles of C, because you need to calculate the ratio of moles of that particular component divided by the total moles. Similarly, if I ask you, mole fraction of B will be moles of B upon total moles, which is moles of A plus moles of B plus moles of C, right? So I can say that mole fraction is denoted by chi. If I ask you, you have to calculate the mole fraction of C, you will say moles of C upon total moles, which is moles of A plus moles of B plus moles of C. So basically it is a fraction of that particular component whose mole fraction you are calculating to the total number of moles. Another important thing which you need to note here is that if you add the mole fractions of all the components present in the solution, which means that if I add mole fraction of A plus mole fraction of B plus mole fraction of C, what will be? It will come out to be equal to 1. Let's see. Don't trust me like this. Apply and then trust me. So this means that mole fraction of A is Na upon Na plus Nb plus Nc plus moles of B upon Na plus Nb plus Nc plus moles of C upon Na plus Nb plus Nc. If you will write it like this, you will get Na plus Nb plus Nc upon Na plus Nb plus Nc, which is equal to 1. So this is how you will calculate the mole fraction. Two important informations that we have now deduced is that mole fraction for each component is its unique value. If you add the mole fractions of all the components, you will get total value equal to 1 because it is a fraction, right? Yes. So this is what is most important. So you can just note it down and then we'll move forward. I hope you've written it. Now let's move forward. Now let's try a question how to apply the mole fraction part. And my dear students, let me tell you this mole fraction is actually the most important part because this will be used in the complete solutions chapter. Okay, so the question says calculate the mole fraction of H2O in a mixture containing 0.4 grams of NaOH in 1.8 grams of water. So basically you have a binary solution. You have one component NaOH and you have one component water. We can calculate the moles of both of them. So moles of NaOH will be equal to given mass, which is 0.4 upon molar mass, which is 40. This will be 1 upon 100. Next is moles of water. Moles of water will be equal to given mass 1.8 upon total number of molar mass, which is 18 grams per mole. So this will be 1 upon 10. I hope this is clear. You have to calculate the mole fraction of water. Now, if I see mole fraction of water, then that will be equal to moles of water upon total moles. And there are only two components. So, moles of NaOH plus moles of water. So, moles of water are 1 upon 10 upon moles of NaOH is 1 upon 100, and this will be 1 upon 10. This is 0.1 upon 0.01 plus 0.1, which will be equal to 0.1 upon 0.11, which is equal to 1 upon 1.1 or 10 upon 11. So this is the mole fraction of water. Okay, this is clear to you. I hope there's no issue. If I ask you, my dear students, that can you calculate the mole fraction of NaOH? You say, of course, mole fraction of NaOH will be equal to moles of NaOH upon moles of NaOH total moles plus moles of water. What is the moles of NaOH? Moles of NaOH is 0.01 upon 0.01 plus 0.1, right? And this will be equal to 0.01 upon 0.11, which is equal to 1 upon 11, right? So you will say this is the mole fraction of NaOH. But I want to tell you one very important thing, which is since you know that it is a binary solution, right? Yes, it is a binary solution. It has only two components. And you know the mole fraction of one component, let us say water. So can you say that mole fraction of H2O plus mole fraction of NaOH will actually be equal to 1? And if you know the mole fraction of H2O, you've calculated it to be 10 upon 11, then mole fraction of NaOH can be calculated directly. Mole fraction of NaOH will be equal to 1 minus 10 upon 11, which is equal to 1 upon 11. And this is exactly the same value which we calculated by doing this complete calculation. So what I want to tell you is that whenever you have a binary solution, you need to calculate the mole fraction of only one part. You can subtract that from 1 and you will get the other mole fraction also. So you need not calculate the complete part, right? Yes, this was very important to apply, right? Yes, I hope this is clear to you. Very good, my dear students. Let's move forward. First, we'll complete the concentration terms and then we'll do the questions. The last concentration term is ppm. What is ppm? ppm is parts per million. What is ppm? Parts per million. It is exactly how we calculated the percentage part. This time you're calculating out of million. Okay, let's see. What does this mean? This means that mass of solute in grams present in 10 raised to the power 6 grams of solution. Present in 10 raised to the power 6 grams of solution. So if you have a example, let's take an example. You have 10 ppm NaOH solution. So what does this mean? That you have your NaOH as your solute. You will say you will have 10 grams of NaOH present in 10 raised to the power 6 grams of solution. So can you see that it is exactly same as the percent part? In percent part, out of cent, that is 100 you were calculating, and in parts per million you will be calculating out of 10 raised to the power 6, which is 1 million. Let's write the formula. I hope you can write the formula on your own as well, right? Yes. So ppm will be equal to mass of solute, again in grams, divided by mass of solution in again grams into this time 10 raised to the power 6. This is the only difference in parts per million, and this is the major difference in parts per million and the percent part, right? Easy. I hope you'll do this. There's no issue here. Perfect. After this, there is one more concentration term which is not generally asked, but I need to tell you, which is ppb. This means that parts per billion. Parts per billion. What does this mean? Exactly same as parts per million. This time you will have mass of solute in grams present in 10 raised to the power 9 grams of solution. This time you will calculate out of 1 billion. 10 raised to the power 9. Everything is same. Calculations will be same. Everything will be same. Only the factor 10 raised to the power 9 will change. Example, my dear students, you will have, let us say, 10 ppb aqueous NaOH solution. So what does this mean? You have 10 grams of NaOH, your solute present in 10 raised to the power 9 gram of solution. And if you are asked to write the formula, will it be any difficulty? No, ma'am. Super easy. Super easy. ppb will be equal to mass of solute in grams divided by mass of solution in grams into 10 raised to the power 9. Easy. Easy? I know it is very easy. Chemistry is very easy. If you can understand it. If you want to memorize it, I cannot help you. But if you want to understand it, ma'am is always here for you. Right? Yes. Perfect. Very good. So now we are going to solve a question. So now, my dear students, we are going to solve a question. Very important question. Okay. So here, not this question. I'll give you this question as your homework. This is your homework question. You can do this question. Very easy question. See, I'll give you a hint. You have to calculate the mole fraction of NaOH, and it is given that you have 40% mass by mass solution, which means that you have 40% mass by mass solution. So you will have to find out 40 grams of solute is present in 100 grams of solution. You will calculate the mass of solvent from there, and then you will calculate the mole fraction of both of them, right? Yes. So this is important that you understand that what are you going to do? You have to use this formula. Mass of solution is equal to mass of solute plus mass of solvent. Use this formula. I am telling you this formula will be used. Okay? Ma'am has given you the hint. Now you cannot. I mean, now I think you can solve the question, because since aqueous is given, I can also say that solvent is water and your solute is NaOH. Just calculate the masses of water and NaOH, calculate their moles, and then calculate the mole fraction. Super easy, right? Yes. Now, my dear students, since we have completed all the concentration terms, I am going to tell you about one very important question. And then we'll end the session today. Okay. So here is a question, and which is very important. This question says that you have to calculate the molality of an aqueous solution in which the mole fraction of solute is 0.25. See, so basically you are going to find out the relation, between mole fraction and molality. And in a lot of PYQs, this type of questions are asked. See, so let's try this question. Calculate the molality. So you know that molality is actually moles of solute upon mass of solvent in kg, right? Yes, this is the formula for molality. See, now how are we going to do this question? We are given the mole fraction of solute as 0.25. Let us say that mole fraction of solute plus mole fraction of solvent will be equal to 1. I know this, and I know that mole fraction of solute is given to be 0.25, and also I know that mole fraction of solute is 0.25. So if it is a binary solution, can you calculate the mole fraction of solvent? Yes, ma'am, it is very easy. This is 0.25 plus mole fraction of solvent is equal to 1. So, ma'am, mole fraction of solvent is equal to 1 minus 0.25, which is equal to 0.75. Right? Yes. So, this is the information which you have calculated. This and this. Right? Yes. No issues till now? Perfect. Now, what I want to tell you is that what you have to do is divide these two. You have to take 1 and 2. Okay. Do you know that mole fraction of solute is actually equal to moles of solute upon total moles? Right? And also you know that mole fraction of solvent is moles of solvent upon total moles. If I divide 1 by 2, what will happen? Divide 1 by 2. What will happen? You can say that mole fraction of solute upon mole fraction of solvent is equal to, see, moles of solute upon total moles, right? So moles of solute upon total moles divided by moles of solvent upon total moles, right? Yes. And this also equal to 0.25 upon 0.75. Yes, ma'am. So this is only equal to 0.25 upon 0.75. Clear with this part? Clear with this part? This means that this total and this moles total can be subtracted. So from here, I have found out something very unique. What is that? Let's write here. Mole fraction of solute upon mole fraction of solvent, which is equal to 0.25 upon 0.75, is actually equal to moles of solute upon moles of solvent. Means whatever the ratio of mole fraction is coming, that is same ratio for ratio of the moles. See, I just wrote what we have calculated here. Right? I hope there's no issue. Perfect. Now, what I want to tell you is that we also know that molality is actually equal to this. So molality is equal to moles of solute upon mass of solvent in kg. See, if you talk about mass of solvent, and you are given moles of solvent, what will happen? Can you say that, ma'am, for solvent, moles of solvent are actually equal to given mass of solvent upon molar mass of solvent? Yes, we can say that, right? Moles of solvent is equal to whatever is the given mass of solvent upon the molar mass of the solvent. So what will be the expression for mass of solvent? Moles of solvent into molar mass of solvent. Yes or no? Yes or no, my dear students? Just tell me this. Is this true or not? Yes, this is true. Yes, this is true. Yes, perfect. Okay, clear? What have I done? I just used this expression. If you are supposed to calculate the mass of solvent, and if you are given the moles of solvent, then how can you calculate its mass? You can calculate by multiplying the moles into molar mass. I used this expression. I've used this. If I put this into this, right, what will happen? Just see. Molality is equal to moles of solute upon, see, mass of solvent, and mass of solvent is equal to moles of solute, solvent into molar mass of solvent. So moles of solvent into molar mass of solvent, and this will be in grams. So if I have to convert it into kgs, I'll have to divide this part by 1000. If I'll divide it by 1000, that means that I am actually dividing it by 1000 like this, right? Yes. The question is solved. It was very easy. See, for molality, you need ratio of moles of solute upon moles of solvent. Do you have ratio of moles of solute upon moles of solvent? Yes, you have. This is equal to 0.25 upon 0.75 into 1000 upon solvent molar mass. You need solvent's molar mass. What is the solvent's molar mass? You have seen that it told you that you have a aqueous solution, and if aqueous solution is written, this means that solvent was water. So the molar mass of water is 18 grams per mole. So this means that you know the molar mass of solvent as well, which is 18 grams per mole. So just solve this. This is 1, this is 3, this is 1000 by 18 into 3 molal. This is how you are going to solve the questions when you're given mole fraction and you have to calculate the molality. So here, if you want to memorize a formula, you can memorize this formula. I'll write this formula again, my dear students. Molality is equal to moles of solute upon moles of solvent into 1000 upon molar mass of solvent. This formula is very important for you because many times this question has been asked, right? So here mm of solvent is actually your molar mass of solvent. Okay, and this is moles of solute, moles of solvent. I hope there's no issue here. I'll just explain you the complete process again so that you will be clear with this concept. See, I know that molality can be calculated as moles of solute and upon moles of molar mass. Molality can be calculated as moles of solute upon mass of solvent in kg. If you are given moles of solvent, then can you calculate the mass of solvent? Yes, ma'am. If I write it mass of solvent as moles of solvent into its molar mass. Right. So I use this expression here. So from here, I calculated the formula. Because the mass was in grams, so I had to divide it by 1000. So this is the final formula for me. Right? Yes. So I just somehow need to calculate the ratio of moles of solute to moles of solvent, and I'll be able to calculate the molality. Also, I was given the mole fraction of solute. I know that it is a binary solution. So mole fraction of solute plus mole fraction of solvent should be equal to 1. This means that mole fraction of solute will be 0.25, then mole fraction of solvent will be 0.75. Mole fraction of solute actually is equal to moles of solute upon total moles, and mole fraction of solvent is equal to moles of solvent upon total moles. If I divide the both of them, I get the ratio as this. This means that whatever is the ratio of mole fraction, actually that is equal to the ratio of the moles of solute and solvent, right? Yes. So I used this expression and calculated the ratio, used it in this expression, and I've calculated the molality. Super easy, right? Yes. If you are clear with this concept, then my dear students, ma'am is going to give you a homework question. This is your homework question, and this question has been asked previously in NEET as well as in JEE. Just check out. What is the mole fraction of solute in a 100 molar aqueous solution? This is same. It is based on the same formula. It was asked in NEET, and there is one question which was asked in JEE as well. Where is the JEE question? Okay, I'll show you the JEE question in the next class. I don't have the JEE question right now here, but I'll show you in the JEE part also that a JEE question was also asked on the same formula. Okay, so this is a very important part. So you have to do this question. Okay, yes. Now, ma'am is going to give you some homework questions as well. Calculate the mass percent of 10 ppm aqueous solution of CaCO3. What are you going to do? See, you have 10 ppm CaCO3. What does this mean? This means that you have 10 grams of CaCO3 present in 10 raised to the power 6 grams of solution, and you have to calculate the mass percent. So for mass percent, what do we need? Mass of CaCO3 upon mass of solution into 100, because this is mass percent. So from this part, we've calculated this. What is the mass of solute? 10. What is the mass of solution? 10 raised to the power 6 into 100. This will be 1 upon 10 raised to the power 3, which is 10 raised to the power minus 3%. This is how you had to solve this question. Just write what you are given and just write what you need to calculate. You can solve any question, any question. If you are clear with this concept, then this is your homework question. Mole fraction is given, you have to calculate the molality of the solution, okay? That mole fraction part, homework question. And again, my dear students, this is your homework question, okay? You have to solve this part as well. The maximum practice you will do, you will be clear with the concepts. Don't memorize anything. Don't try to memorize the questions because question will be different. Okay, so you have to solve these type of questions yourself. I have given you a lot of homework questions, my dear students. And with this, let's come to the end of our session. So today we have discussed a lot of concentration terms and a very important part of solutions chapter as well as mole concept chapter. So basically you have revised 12th as well as 11th. So my dear students, do practice a lot of questions. Try to be clear. Don't be scared. My motive would be, my advice to you would be that your motive should be that you have to solve the questions on your own. Be it anything. If it takes 5 minutes, if it takes 10 minutes, no issues. You have to try and solve the question yourself. Once your fear of solving the questions is gone, you are going to excel, let me tell you. So just be very confident because the competition is you. So you have to be very confident and try the questions yourself. And do let me know how many questions you were able to solve on your own. And then we'll I'll try to solve a lot of more questions in the coming sessions as well. Okay. So with this, let's end the session. Thank you so much, my dear students. Keep studying. We'll meet in the next lecture. All the very best.